Welcome everybody to Dallas Personal Robotics Group Robot Builders Night Virtual for April 7th, 2026. Tonight we will go through our normal roundtable presentations and then open up the floor to questions or discussions. I have a couple of reminders. One is our Roborama Club competition coming up. It will take place on Saturday, May 23rd, I believe is the date. And the events will include quick trip, line following advanced, barrel racing, 6-can, 4-square, sumo. It will take place at the Dallas Makerspace. So if you're in the area, you may want to show up and attend. I promise it's going to be a great event. The other one that's happening this Saturday, I believe. Let's check the date. Yeah, this Saturday. There's a line following parade. Dallas College Eastfield campus is hosting the event to take place on the 11th. A couple of the club members are working on a robot designed to tow a float while maintaining a distance to the lead robot on a line following course. So I think that's going to be an interesting event to watch, and hopefully it goes off well. Incidentally, I don't see either of the club members that are working on that right now. They must be too busy getting things ready.
Are there details on that anywhere? Like is it on a website or anything?
I'm not sure if there was something posted on Discord. But it's Dallas College Eastfield campus is the one hosting it. So maybe they have something posted on their site.
I think Doug posted something on it on the Discord or on the news group.
Oh, in the DPRG list server.
Right.
Okay.
I think Doug posted something there.
Okay, thanks.
If I remember right.
Okay. What else do I have? I have nothing else for club business. So first off, we've got Mike, who's going to present an update on his barrel racing robot he's been working on.
Well, I've been trying to add barrel racing to my robot, and I've been completely distracted by other things. But I think I have it going around the barrels. I have it going really slow because when it's making turns. Oh, what I'm doing is I'm sensing the barrels with sensors, and instead of just doing a predetermined route. And when you go in circles, you know, you're rotating, going around. The sensors lag, and I got to figure out how to mathematically compensate for that, so that it runs good when it goes fast. So it's going to go really slow right now. So it's the robot that I used last year that does the 6-can and the 4-square and stuff. So let's see if it works. Hold on. Yeah, I mean, this is really dangerous to do because it just did it the other half hour ago. So, I'm starting it up. It's ROS, so it takes forever to boot. So I'm gonna wait until it's ready. And sometimes it doesn't come up. Oh, I got a fail. I got a failure. Can Ray do his first?
Okay, let's see if Ray is ready to go.
Can you hear me?
Yes, I can.
Yep.
Okay. I'm going to turn this down. Okay. No echo?
Not yet.
Okay, good. All right. This is a mecanum wheeled platform it's got the MaxCam camera on it and an IMU and 2 distance sensors. One distance sensor points forward and the other points to the right. And what I was trying to do is, when the robot gets turned on, figure out what its angular orientation is and store that as like an initial heading. And after it goes and finds the can, what I wanted it to do was to get back to that, or point it back to that initial heading, and then use the distance sensors to move left or right to get to the center of the course. And then once it's in the center of the course, move forward, sensing the distance from the right wall. So when it sees the goal wall or passes by it, there's a big change in distance. And that's when it knows to stop because it found the goal. So let me see if I can play it. I don't know if the audio is going to work on this or not, but if not, I can.
Ray, you might want to turn the volume down on your phone or computer, one of the two.
There's a little echo. Yeah.
A little bit of an echo.
It's moving. Oh.
Can you hear the audio?
No.
No. Okay. How about now?
Nope.
No? Okay. All right. What I can do is just talk over it then. Okay. I'm going to start it over. Boop. Okay, so I've got it parallel to the wall, and what I can do is just turn it on. It should take that initial heading reading and then move left or right to get to the center of the course. Anyway, so I haven't turned it on yet. Okay. Anyway, here we go. To the center. Right. And this white fold in the paper is okay. Stop. Bring it back 10 seconds. And I'm just checking the move to goal functioning. So there, it found the center again. It started to get a little off. I have to get a little more aggressive with the adjustment. It lags too much. I don't allow enough of it to influence the steering. But center again. So it finds the center, moves forward, and should stop when it sees the goal wall.
Hey.
And it's going pretty slow right now. I can speed it up quite a bit. Anyway, that is, get out of all this.
So is this using that your beacons?
No. This is just using one of the Polulu pulse with output sensors. I forget which number it is. It's good for, I think, 300 centimeters, 3 meters. And it seems to work pretty good. Let's see if I can get out of this.
Yeah, I guess I remember your sensor for your beacons was pretty big compared to that robot size. Yeah.
Yeah. I don't know. this was the cover that went over it. So it's that's maybe maybe 4 inches or so, a little more in diameter.
Oh, that's not bad. Yeah, I thought.
Yeah.
The pictures I saw, I thought it was bigger, but okay, good.
Anyway, so the idea was to, you know, just use the distance sensors and an IMU. Oh, this thing's going to drive me crazy. It's got an echo. What do I can't turn that down? Anyway. Okay. So basically, you know, I just wanted a minimal amount of sensors on it. And I was even thinking of using like 2 distance sensors, one on the front and one on the back, and using that to align it to the course wall.
Mm-hmm.
And, but I still need to, like, after I get a can, it's going to be in some unknown angular orientation with respect to that initial heading. So I want to get back to the initial heading because that points to the goal that I want to go to. And then I want to get to the center of the course and then move forward. And that should get me positioned at the center of the goal. So no matter where I am on the course. And what I found before is like the distance sensors work pretty good on the long stretches of the wall, but when you get to the corners, you know, it can throw you around. So if you don't know what your initial orientation is, it can bypass the goal that you want to go into and go back to the goal that you don't want to go into.
Oh.
And so anyway, so that seems pretty reliable, pretty repeatable. And I've got to turn off my phone now because it's driving me crazy. Anyway, that's all I had.
That's excellent, Ray. That was in autonomous mode, correct?
Yeah.
Well, I gave you our first gold star of the night. Oh, Paul's going to find his star. We haven't had his star since he left. There you go, gold star.
Gold star.
That was good, showing some good progress, right? Okay, Mike,
I can't hear you guys. Can you hear me?
Yes, we can hear you.
Shit.
Yeah. Okay, well,
that too.
There we go. Sorry, I missed that. Like I might
we can hear you saying the 4-letter word.
Huh?
We can hear you saying the 4-letter words.
Oops. Maybe we can edit that out later.
Yeah.
Can't edit it out. Okay.
Yeah. So my robot, when I'm doing the barrel racing, it senses the location of the cans, and what I do is I sort of know the general layout of the place, and so I go in a general direction and get close, relative, you know, get sort of close, and then I use the camera to pull in a little further, and then I use the LiDAR to go around the can, because the LiDAR can see the sides and the camera can't. So then it exits the first can and then heads towards and goes to the second can for, you know, a meter or so, and then it looks at the camera to go closer, and then switches to the LiDAR. So that's my technique. Yeah. So let's see what happens. Let's see if it can come up again without an error. Ross is driving me nuts this year. I don't know why. It's supposed to be the same as last year. Yeah, last year is working pretty good. I'm using Humble, so.
I'm just wrapping up my migration to Jazzy. It's not as bad as I thought it was, but it's there's a few things to get right. changed.
I used Jazzy for my outdoor robot last year, which
All the cool kids are using Jazzy.
yeah. But this one just works. I said, hey, it works, so I'm just going to use it. Okay, so it looks like it's up and running. Let's see what happens. I'm gonna sort of point the PC camera to my field. You can see the robot starts there, and then the third barrel is right there. So let's see what happens. Here's my remote, so I can start it. And oh, remember, it's going to go really slow. It's moving. So this is the first scan here. Okay. So this is a pre-programmed motion, and then it switches to sensors. Now it's going to go around the can.
Oh. Haven't been to the rodeo in a while. I forgot how barrel racing worked. Thought you would have went the other way.
Yeah. And I think this is the right way. And then this is the yeah. So now it's going to switch to sensors again. Yeah. Yes. Yeah. Because
I don't think the rules care, but in real barrel racing, I think they usually go to the left barrel first.
Doug has it, he has a picture with the course on it. In the
the Roborama rules are left, right, and then the center.
Oh, it's disappearing out of the frame.
Oh.
Combination.
And I haven't perfected getting back to the starting point. I figured that's relatively easy compared to this. So, uh-oh. It's not an auto course. There's nothing.
Oh no!
Well, it's disappearing out of the frame again.
I got to work on the.
Lost your rider.
I got to work on the angles. Okay, it stopped.
What's the penalty for hitting a can?
Very cool. Very
So-
cool.
So that is my barrel racing on a really, really slow.
Yay, gold star.
That's
Yay.
a gold star, yes.
So did you say you were?
And I did it live, which is even harder.
So are you trying to compensate for the LiDAR as you move?
What do you mean
Or-
compensate?
Well, because as you're moving forward, the frame of reference of the robot changes. So each scan, you really have to add like a distance that you've gone to get the perspective correct again. Otherwise, it looks like straight lines appear like a sloped line.
Well, that's why I'm going really slow. Yeah.
Oh, okay.
So the
Oh, I
source
thought
is-
earlier you said you were trying to compensate for something. I didn't know if it was the LiDAR or the distance measurement devices.
Yeah.
Or
Yeah, because you probably didn't notice it, but on the second barrel, it was further away from the can than the first barrel because it changed directions, and the can was further. Well, was at the end of the scan pattern instead of at the beginning. So I got that kind of compensation to work on.
So
The concept works.
you said several times that it's switching to sensor mode and then it would use the camera and the LiDAR. But what was it using before it was switching to sensor mode?
Well, I was just running with I know what direction I'm going, and I also have odometry, so I know what direction I'm exiting. So I go around the can and I say, okay, at 80 degrees, exit. Stop going around the can and go straight. And that should be heading towards the other cans, which can be in like there's a couple feet of difference. So you don't know exactly where the cans are. And then it sort of heads in that direction, checks out the camera and says, oh, there's a can, and makes a correction. And then the camera detection isn't that precise. And then it, well, it's pretty precise when you get close, but then it switches to the LiDAR, which is really precise, except for the motion detection. Except it has a problem with motion. The the LiDAR is spinning, and while you're moving, and especially when you're spinning and the LiDAR spinning, it gets a little flaky. So
so prior to the camera picking up the can, it was using odometry and just like following a path to a coordinate or driving to a waypoint using odometry. Is that correct?
Oh, well, it was basically I'm pointing in a certain direction, like the first direction, you know where you are. And so it's just a timed movement.
Oh, okay.
So I just time it and let it go because I know what speed I'm going. So I just go at a certain time. Okay. And then when I get past the start line, I go to a second state, which does a rotation to turn towards the first can. And then after that rotation, I'm pointing at the cans, and then I go towards them, and then use the camera to get closer, and then start using the LiDAR to go around the can.
Okay, thanks.
And then when it goes around the first can, it uses odometry to know I'm at 80 degrees or something. So at 80 degrees, I know I'm pointing to the second set of cans, and then I just time it for a meter, and then switch over to the camera and the LiDAR and go around that can until a certain degree, and then yeah. So it's a state machine, yeah. But instead of trying to know exactly where the cans are and predetermining a route, I just let it use the sensors to go around to take care of the variability of the plan. Like the barrels can be within 2 or 3 feet of each of them. Yeah, there's some variability. It's not like precisely placed at this point and precisely placed at that point. So.
Oh, cool. Thank you.
Yeah.
Nice.
Well, I'm happy it worked. Yay.
Yay.
Always nice when that happens.
Yeah. But getting back to home hasn't been debugged at all. Like 5 minutes before it, I said, okay, whatever angle you're at, I forget, I didn't tune it. Just keep going for a meter. It was heading straight to the other can, and it didn't know any better. So yeah, I'll make it better. So I'm done.
Well, thanks, Mike.
Oh! I got one more thing while I got people. I have I'm thinking of switching my router that I put on my robots to this here, which is a little module. So it should have a smaller footprint on the robot, and it has big antennas, so it should be a little stronger. So I'm going to try this router instead of that big box, right? Retail type box. So,
what kind of a router is that?
It's a Wi-Fi repeater with an Ethernet cable to plug into the Pi, and a power supply right there. So,
whoa.
So I was going, hey, that's pretty cool. I'm gonna try it, something different. And I turn it on and it works, but it doesn't work the way that my current router works. And I like the way my current router works. So it's like, I'm gonna see if I can figure out how to use it. I'm gonna try to figure out how to use it, and that makes me happy. And we'll see.
Any English documentation with it, or was it all?
It was.
Take a wild guess.
Wasn't bad. Wasn't bad. I mean, here's Here's the manual. Yeah.
Oh,
Oh,
not so
yeah.
much tinglage.
And yeah, so it has little pictures and drawings.
Mm-hmm.
Yeah, pretty good.
Is it made by IKEA?
But yeah, the what do you call it? The web page on it to control it is a little. It's not well tuned, but it's functional. It's basically it's like, oh, this is something that I would build, not a highly polished interface.
Well, thanks, Mike.
Mhm.
Next up, we have Paul. Welcome
okay.
back, Paul.
Well, it's good to be back, guys. It really is.
So where were you?
Oh, you don't know the story? I've been on a sailboat for 3 months.
Wow.
Starting in Phuket, Thailand, and sailing to the Maldives. And we spent about a month in the Maldives, which is a bunch of atolls just south of India, just a little southeast of India, and then sailed over to Socotra, which is a little island just south of Yemen, and about 200 miles south of Yemen, far enough that we don't have to worry about the
Virus.
civil war going on there. And
Mm.
then to Djibouti, which is a city on the Horn of Africa, surrounded by Somalia, Sudan, and Ethiopia, and then up the Red Sea, stopping in Jeddah in Saudi Arabia, and then finally to Egypt and the Suez Canal. And I got off in the Suez Canal and went to Cairo and saw the pyramids, and that was 3 months right there. It was like, ooh, it was a
Great.
big trip.
Yeah, sounds like it.
But yeah, we had Starlink most all the way, and so when there was nothing going on and I didn't have to keep an eye out. Oh, we saw the most humongous ships. Some of them, so you have an AIS display that shows the ships around you, and you can request details on the ships. And some of a lot of them will show their length. Typically show their length as like maybe 600 feet, 800 feet. Some of them showed their length, the tankers, as 0.28 miles, 0.28 nautical miles long.
800 meters.
Just the most enormous things that you ever saw. Anyway, when I wasn't on watch or busy, I took my laptop and actually took my little robot and tried to make it work, but it didn't like the deck. The deck wasn't smooth enough for it to be happy. So the guy, many of you know, I've been involved with LinoRobot 2, and the guy who owns the repo and had put together a set of GitHub pages. So GitHub has this kind of neat feature called GitHub Pages, and you find it down like in deployment to GitHub Pages, but you can set it up in settings under Pages, and basically it generates a static website from a branch and the directory that you tell it where to publish from. And so that's what's going on here. So if you look at the code in the docs directory, which is where all of these files are kept, you have a whole bunch of markdown files, and GitHub Pages turns markdown files into web pages on a static website. So it's
I gotta take my medicine first.
what?
David, can you mute your mic, please?
Yeah, sorry about that.
Yeah, so GitHub Pages turns markdown files into web pages. So that's what I'm showing here is, and you know, before too long we'll get the website at LinoRobot.org to point to this set of pages. And so the owner of the repo set up, he wrote the overview, beginning of the overview, installation, base controller, odometry. So basically a journey through building a LinoRobot. And then I amped it up with sections like why LinoRobot 2? What are the reasons why you might be interested in that? And tell you what, let me just paste this into the chat. Okay. And why not? You know, when's it not suitable? Define a bunch of terminology, define system requirements. I wrote an architecture page. So here's a picture of the system architecture for a physical robot, where you got a workstation talking to robot software. This is ROS software that may be running on the workstation, or it may be running on a Raspberry Pi or an x86, some kind of computer that's on the robot. And then that talks to robot firmware that's on a microcontroller. So this is all very standard robot architecture stuff, and the microcontroller runs the motors and the sensors. And then it also supports simulation. So the same software, same robot software, will talk to the simulated robot, and I've demoed that in the past. And so anyway, there's all kinds of diagrams here on the architecture of the thing. And then I did a page on supported system configurations. So you got there's like two groups of system configurations. One for a physical robot, where the first configuration is an onboard robot computer, and the second is robot Wi-Fi, where the robot software runs on the workstation and communicates with robot firmware running on ESP32 over Wi-Fi. And then there's a second group of configurations to do with simulated robot system configurations, where you've got the simulation configuration is one where robot software and Gazebo simulator run on your workstation. So workstation, I'm talking a PC here, Linux PC, or potentially Docker running on WSL under WSL2, maybe. And then the second is cloud simulation configuration. So that's where robot software and the Gazebo simulator run on a compute node in the cloud, and the GUI tools are displayed on a virtual monitor in the compute node in the cloud. And then you run VNC in a browser in your workstation that connects to the virtual monitor. So anyway, I did diagrams of all this stuff. So here's the onboard robot computer, where you got a robot computer running ROS and the nav2 stack, and then a microcontroller running micro ROS and the LiDAR and depth sensor feed ROS. And then here's the robot Wi-Fi configuration, where the microcontroller sends LiDAR data and Wi-Fi up to the workstation, where ROS runs up there, and RViz runs there. And then a list of advantages and disadvantages of each. And then for simulation, you've got the normal configuration, where you run Gazebo and ROS nodes on the workstation, and it all simulates the robot, advantages and disadvantages of that. And then a cloud simulation, a cloud compute simulation configuration, where all of that stuff, instead of running on your workstation, can run on a cloud compute node. And the significant point about that is you can rent high performance solutions with like tons of NVIDIA GPUs to speed up the simulation. And then you have a virtual monitor that displays in a browser window that lets you pull up RViz and all the other good ROS GUI tools. So that's the most of what I did. The installation is the next section, and that's I think I've got that done. Works installing robot firmware in the build system. So how to install platform IO and download and build the robot firmware, how to install for the simulated robot. The next sections that I have to, so these remaining sections are written from the ROS level perspective, but there's nothing in there about the hardware, like how to configure how to set up the config file so it knows what your wheel size is, what your wheel spacing is, how many counts per revolution the encoders provide, and whether there's an IMU and all that kind of stuff. So currently this is, so from base controller on down or base controller down to setting up sensors, I think are the three sections that I need to add hardware information to and pull that out of a combination of places where it's currently documented in LinoRobot hardware, and so I'm going to pull it all into this web page view, and this will be the main documentation for LinoRobot and how to do it. So anyway, it goes through, once you get through like building up the robot and setting up its physical robot and its transforms, you get into mapping and SLAM mapping and procedures for launching the mapping software, making a map, generating the map, and there's some animated graphics in there. It's saving it, navigating through the map. This is a section. So, oops, why did it flip? Section on navigation here, and some animated GIFs on how to get the robot to drive, and so anyway, it's a pretty nice website. I have been I've added probably about half of what I'm going to add, and it's a work in progress at the moment. And this where he gets it navigating, and then the robot goes, and all this stuff works. I've had it running on Minibot. So anyway, it's good stuff. And then there's a section on Docker, how to configure Docker, especially if you're using CUDA with CUDA with NVIDIA GPUs, which is particularly applicable for when you use a large compute node in the cloud with tons of GPUs. That's how Juan Miguel runs it, does most of his simulation. And here's how you set up the web visualization and then a kind of a neat thing that he did, he wrote this program that converts image to gazebo. So it'll take a map that is in when you generate a map from nav2, or you can have a map that's an image like a PNG file. But if you use SLAM to generate a map, it generates a PGM file, which again is just a kind of image, and it extrudes the boundaries of the map or anything that's black in the map into solid walls, and you can then run that in Gazebo. And so what I was doing, partially successfully, the bumps in the floor made the physical robot not run well, but I'd used SLAM to make a map of my cabin on the boat, and maybe I'll demo that next time. And then I extruded that, used this tool to turn it into a simulation model. Then I could run the robot in simulation inside of the real map that I generated using SLAM from the real, the real space that was going to run in. So that this is sort of, in a way, it closes the loop of having a digital twin, where you can go backwards and forwards between the physical robot and the simulated robot, and have the two have hopefully a reasonable correspondence. So anyway, that's all I have is that I wanted to show is the work on this web page, which is ongoing, and yeah, so that's it.
Yeah.
Well, thanks, Paul.
Yeah. So when you're like, you can run your robot on a native Ubuntu, but when you're doing the cloud simulation, that's when you have to use Docker, I guess.
Yeah, because you wouldn't have Ubuntu in the cloud, so you just run it under Docker. I haven't actually done that. It's how Juan does it. And interestingly, the reason he chose to use the virtual monitor running in the cloud node and then VNC back to his workstation is, as you know, the normal configuration of ROS is you'd run RViz or other graphical tools on your workstation, and they get lots of ROS messages from the compute node, from the simulation. Well, running that across the web was running his well, he took a sharp breath inwards and said, that was expensive.
Especially for Starlink. Yeah.
To run all those ROS messages from a compute node in the cloud down to his workstation, down to RViz on his workstation. So he came up with this alternate solution of having a virtual monitor in the cloud and then VNCing into the cloud node, and just having a browser-based VNC client. And I mean, I guess you could use a separate VNC client. I don't know. I haven't tried that path yet. But anyway, that was the motivation. Was the comms costs apparently got pretty extreme for running ROS across the internet from your cloud node.
Yeah. So I'd like to try Lino on my robot that you saw running around here, because it's pretty basic. It can be pretty basic like that. The LiDAR and the Oak D light, and Raspberry Pi and a Pico. How easy is it to add like a custom sensor to it?
It's easy when you know how, like everything, right?
Yeah, I mean, I can run it on mine, so I guess, yeah, if I understood the workings of Lino, I could probably add it to it and then add that to the repository.
Yeah,
as an alternate sensor.
I've looked at how it's done. I added a servo for the can 6-can last Roborama, and it was pretty straightforward.
Okay. Yeah.
You modify the firmware in the expected ways that you would, have you find a piece of code off of Arduino that drives an IO pin and with a PWM to drive the servo, and then the rest of it is to do with getting the messages. So you can use standard ROS messages. So I used I think a float, just a simple float, or maybe an int, I don't remember, and just published it from the ROS side on the PC, and it turned up in the microcontroller. And there's plenty of examples on how to subscribe in the microcontroller to that, and it was pretty straightforward. And there's another example on how to put a sonar sensor in. So there's examples.
Okay, yeah. So you said that the quote standard ROS, the ROS messages that come with ROS, I guess. I've been using custom messages, so I assume there's a way to utilize those too.
Yeah, you can use custom messages, and it's actually let me just reshare this architecture drawing, because I think it's significant. It's a really important point. So going back to the architecture, to explain why custom messages, because being able to use custom messages, as you can well appreciate, is really important. And so this is a protocol stack diagram showing the layers of software that run on the PC that are considered ROS and levels below that, and the layers of software that run on the microcontroller. And the important thing is that the ROS client, the same ROS client library that runs on your PC under ROS, that sits underneath the RCL CPP or the C++ or the Python shims, also runs on the microcontroller. So you can do so you're writing in C over here, you're writing the application in C, not C++, but the concepts are all the same, and the interface in terms of creating a subscription or creating a publisher, and then getting callbacks from the subscriber, or calling to publish a message, and the messages themselves, including custom messages that have a C implementation, and so you can use them over on the microcontroller as well. So that's now I haven't done this myself, so I'm talking theory here, but it's important. It's a significant point that, and one of the design goals of MicroROS was to enable custom messages that you define for your particular widget over in ROS to be used as is in MicroROS and have a subscriber subscribe to them or publish them, whichever way they go, and be able to use those, pass those exact same messages and with the exact same data fields without any modification to the comms protocol between your ROS nodes and a firmware callback or a timer-driven callback, or something of that nature in the firmware. Did that address your question, Mike?
Yeah, basically, yeah. You said it can be done.
Yeah. Yeah.
Okay.
Yeah, and I'd love to, help if I can, but whatever. Yeah.
Yeah, I'm not going to do it till after Roborama, but
Yeah. Well, I should have the documentation fixed up by then, so
okay.
to where all the hardware stuff is in these.
Because it'd be fun just to put this on there and run it with the basic LiDAR and camera, and go, oh, that's cool. Then I go, I really want to use my custom sensors and grabbers and stuff like that.
Yeah. It works pretty neat. Let's see. You guys have seen the simulation before, so I won't do that. But yeah, that's it's working stuff. It's pretty neat.
Thank you. Yeah. Welcome back.
Thank you. Good to be back. It was a long time. 3 months.
Yeah.
3 months on a sailboat.
Yeah, you're lucky to be out of the Middle East right now.
He was there.
Yeah.
Yeah. There was
He's close.
There were a lot of, the war was about 6 days old when the first group of sailboats wanted to head up through the Strait of Bab el Mandeb from Djibouti up the Red Sea, and they all held back for a while and wanting to see whether things would get dangerous in the Red Sea, and they didn't. And so there was one day when like a group of about 6 boats decided that they were all going to go, but they didn't bother to look at the weather too hard, and there was a strong northerly blowing down the Red Sea that day, and they all beat into giant waves that just got bashed around. I had a bumpy ride up through that section of the Red Sea. And,
well, at least you didn't have to go around Africa on the bottom of it.
No, well, that's the only other alternative is to go around Cape Horn. So it's like really important to be able to get up through that Strait of Bab el Mandeb up to the Suez Canal. Yeah.
We're glad
So
you're safe.
how many were on your boat? How many?
Just 3 of us. There were 5 of us took the trip from Thailand over to the Maldives, and then 3 of us carried on. The owner and his wife, who's both good friends of mine from 30 years back, and myself, and we just like rotate through doing shifts, like all night. You got someone on watch all night, so I always did the like 2 a.m. to 7 a.m. shift, and because it's nice and quiet, and you just you can like gaze up at the stars, and you see, I'd count how many shooting stars and satellites, and occasionally see a plane, and it's just beautiful up there, just beautiful.
Yeah, you got spoiled to seeing the stars so nice.
Oh, just so gorgeous. And some of the shooting stars, I swear one of them was a piece of space junk burning up, because it like came shooting over, and there were like, it was like those sparklers, when you were a kid and you had sparklers and they'd like leave all these sparkles coming off of them. It was like that, left a trail of them as it like shot down east to west. So I figure it was like something falling out of orbit. But yeah, a lot of evenings I'd see 1 or 2 shooting stars, and occasionally I'd see a satellite, and occasionally a plane. It was a neat experience.
That's cool. Trip of a lifetime, or are you going to do it again?
It was a trip of a lifetime. I mean, it really was. I've never done anything like that. Such a long trip, and both in terms of time, 3 months aboard, and distance. We did 4,600 nautical miles, give or take. That's like a fifth of the way around the circumference of the Earth. It's a long way. But yeah, I was invited back to sail across the Atlantic when they complete their circumnavigation. So I guess they like me okay. Well, I hope they do after 30 years.
Did you cross the equator?
I did in 2019, going from Mexico down to the Marquesas in French Polynesia. Across the equator, we had a ceremony where we all turned from you become shellbacks. Before that, I forget what you are before you're a shellback. Anyway, yeah, you make an offering to King Neptune and drank champagne on the equator. Yeah, that was a neat experience too. That was a 3-week sail. This was a 3-month sail.
Oh, what size was the ship you were on?
It's a 58-foot sailboat.
Jesus. That's big.
Very nice boat, and we had adventures along the way. One day I was on night watch. It was about 6 a.m. The dawn was breaking. I was just like, you look around and every 15 minutes you go check the radar, check the AIS, make sure there's no boats in the vicinity. And then the engine just stopped. And I was like, what? And I mean, diesel engines don't just stop. And so I went down. The captain already had heard it and was on his way out of his cabin, and he looked around for half an hour, and then he said, "Oh, the belt that drove the injector pump off of the camshaft had broken, just plain broke. So the injector pump wasn't. Yeah, so no fuel was going in because the injector pump wasn't working. So anyway, we fortunately." The winds were relatively light, and there weren't waves and seas and stuff. So we had an orderly breakfast and coffee while we considered how to fix it. And he has spares for just about everything on board. So he had a spare belt, so he dug that out, and then we started tearing into it and pulling idler pulleys off, and got the belt replaced. And you got to line the injector up with the crankshaft.
Timing marks, yeah.
Yeah, so that the injection goes into the right cylinder at the right time when it's when the piston's approaching top dead center, and damn thing wouldn't start. And we'd like crank it, wouldn't start, crank it. And anyway, we reset the belt a couple more times just to try and get the mark on the injector pump lined up exactly with the camshaft pulley, and when that didn't work, I said, Bruce, because there's nothing easier to do, let's rotate the crankshaft 360 degrees and leave the injector pump where it is, in case it's because it has to only inject fuel every other top dead center, right? Because the other top dead center is the exhaust stroke. Four-stroke engine. So we did that and burst into life. So, adventures like that were, and it was really important that we get the engine going, because we're about 8 hours away from this island, Socotra, and there was not going to be any diesel mechanics on there, so we would have had to sail on another 4 days to Djibouti and then anchor under sail if we couldn't have got the engine going, which is you really don't want to do that, because 50-foot sailboats under sail, and then you're trying to drop an anchor. Not good. So
Captain Ron did it. I think he just chugged in and no.
it could be done, but you would prefer not to.
That's right.
Yeah, so lots of adventures. It was a trip of a lifetime.
Yeah, another trick that you can do is you can crack open one of the injector lines. If you get any air in the pump, it's really hard to get it out and to get the injectors working again, and just let it squirt a little diesel out, tighten it back up. That's usually worked for me.
Yeah.
So was it mistimed? Did you?
Yeah, it was 180 degrees, 360 degrees out of phase. It was injecting diesel in on the exhaust stroke.
Oh, okay. Yeah. Huh.
Yeah. And there was nothing on the engine to tell you, there was like a point on the crankshaft that told you when you were at like the reference when cylinder 1 was at top dead center, but there was nothing to say whether it was top dead center on the compression stroke or the exhaust stroke.
Yeah. Yeah, I have a diesel tractor. It's the injector pump is gear driven, and it has definite timing marks on the 2 gears, so it's pretty hard to screw it up.
Right.
But yeah, if you have no reference, how do you know?
Well, yeah, and they do have timing marks on the camshaft, apparently, I think, but this is a belt-driven injector pump, so there was nothing to tell you, to relate. It had a marking on it to say, when it should be against the mark when the cylinder's at top dead center, but it didn't tell you whether it was top dead center on the exhaust stroke or the compression stroke.
Yeah.
It's okay, dude.
Yeah. So excitement.
So did you do videos? There's I think it's called Back to Basics. It's a guy named Strict and his girlfriend that went like all across northern Australia and made these videos. They pretty much ate what they caught.
Wow.
So, and it was I don't know how many months they were out, but actually destroyed their boat. They had a pretty small boat for being out in the ocean.
Oh.
And a storm came in and it forced the boat, onto the shore, and, basically wrecked the hull. So it was, and they lost a bunch of equipment. So, but yeah, I guess nasty things can happen out in the sea.
Oh yeah.
Yeah.
You're out on your own out there. Yeah, for sure. But anyway, I'm super happy to be back and super happy to be like able to re-engage with everyone in the club and get involved in robots again. I'm still all kinds of projects that I want to get going on. UTD has the chess bots, which I think LinoRobot would be a great solution for the chess bot team. So I worked on a simulation of chess bots, and it's not really working worth writing home about. But and then there's the RoboMower project. So Vlad and Paul Urbanus got RoboMowers from that sale that Sensori had, and so the three of us are planning to do it's going to replace my RoboMow project, my yellow RoboMow project, but hopefully get further this time and actually make it mow lawns autonomously. So anyway, that's I got some collaborators on this project now. So
is the chess robots are they going to run micro ROS on each of the chess pieces and then a workstation orchestrating the whole thing, or?
Good question. I think that's what they should do, but they aren't even using ROS at all at the moment. They've got, but their robots are so basic.
Yeah.
And they don't do anything worth writing home about. They can navigate a chessboard and sort of end up. They have like a downward looking color sensor that looks for the change between black and white, but it is hindered by sunlight. So they like tried putting shields around it, but it's that rudimentary. That's the only sensor they've got. So they can tell when they cross squares, but they're beyond that. They're blind, so they're saying, okay, I crossed 4, now I crossed 5, and so they got ESP32 on these little differential drive robots, and that talks up to some website, and they've apparently got a web app that's supposed to let you tell the robots where to go. But basically, as far as I can tell, it was a senior project, undergrad senior project that they basically got something working to where they could get the robots to drive, and said, okay, that's it. That's as far as we can get.
Semester's over.
The mechanics is there, and they got these perspex pieces that they can sit on top that are chess pieces, but there's nothing that really does anything like being a robot driving around a chessboard.
Sorry, we had to switch the phone because Doug's computer decided to
do a hard drive fail.
do a hard drive fail. Yeah.
Anyway.
Hey, Mark, Doug, good to see you
welcome
guys.
back.
Where are you?
We're at my house.
Yep.
I don't know. Can you see? Where are we? I don't see you.
We're here in the corner.
Oh, okay. Hi, guys.
Yep.
We got some stuff to show you about the April 11th event. So
I'd like to do that now.
Why
don't you go ahead and present?
Oh, sorry.
So Mark has been working on. So this is called it's a line following parade.
Yeah.
We have no idea exactly what we're running.
No clue.
Okay, but the intent was, from the looks of what we were able to assign, is that it's more like a float, okay, instead of a serious line follower. But they may have a line following competition also. We don't know. But anyway, so we repurposed my old line follower, and we got it to where it can track.
Follower.
Okay.
Yeah. Just in case I forgot. Yeah.
Yeah. This thing. And we, you don't have it, but we have a case that goes over it, and it has a ultrasonic in the front, and it tries to keep a standard, constant distance from the robot in front, which turned out to be more challenging than I thought, because of we were trying. We do this because it's a hobby. We don't do it the right way. We do it the way because we have a hobby. All right. So anyway, so I decided to use this new sensor. It's an ultrasonic sensor, but it has a UART interface, and has other interfaces too, but it has a UART interface. And it turns out that this robot that we just showed you uses every pin on the microcontroller except the UART. The UART is pinned out to a little header that since it's a homemade PC board, there's a place for it to connect to. So anyway, we're using that as an interface. We're probably doing somewhere between 6 and 11 samples per second. So it's not perfect. Otherwise, if you take a robot, a piece of wood, and put it in the middle of a curve, 6-inch curve. So you put it in the middle of a 6-inch curve, and a robot comes around the corner, it doesn't see it except for very, very short period of time. So it may stop, may not. But if it's moving, it has no trouble following. But Mark has got this really cool. He did the float part.
Yep.
And when we can show you that.
Yeah. So the way, because we have a space limit, like we have to do it within like 22 by 26 centimeters. This entire like floor, the base size. So with the line follower being what it is, we were initially going to tow a float, but now the float's kind of sitting more on it like a chariot. But
Is
I made the top of the
everybody's
float.
image oscillating back and forth in
Yeah,
size, or is that just
right.
me? Something's
It's
going on.
fluctuating.
I think
Yeah, it's like
autofocus is kicking in.
sizes are bouncing back and forth.
Because Mark
Is
is
that-
coming in closer than Doug, and the autofocus is kicking in on the deal.
Yeah.
Oh,
Okay.
okay.
I don't know. Yeah. But,
That's
Well,
a
you need
new-
to see this if we can.
yeah. So initially, I was just going to do a float with like a couple like robots working at a bench or something. But then I was like, we need something more because they want like animation and sounds. So I ended up thinking about Roborama coming up. I was like, I should do a robot. I should do a line following bot. And the floor plan I had for this is only 15 centimeters by 22 initially. So that's what I had. So I did a line following bot, and like I showed some of you guys last week. Paul, you probably watched the video, Paul. I designed a chain of a system called Magna Rail. So I designed a chain for that, and that was noisy, but it works great. And that pulls around a little line following bot, and I was like, I need more. So I designed a little 6-cam. So I have a 6-cam robot in there as well.
Damn.
So right now, you can see it very well. I'll give you the top view, but the little red thing on the floor over there is like a little mouse.
Oh, look at the
And
dummy,
that is-
look at the dummy 13s. That's awesome.
Lots of dummy themes. It's the quickest way to print. So yeah, I've got a little mouse as a line follower, and then I kind of just threw together some primitive shapes for the 6-cam. So yeah, you can see that very well. But it's carrying a little can, a little orange tape can, because we need the orange cans because that's who we are. But yeah, so there's I can't open it up now because I've sealed it, but there's a track that runs underneath both of those. So I did that, and I was like, it needs more. It needs light. So there's also 84 NeoPixels around the sides. You'll see that in a second because it's kind of noisy, but then I thought I needed more. So in the initial design, I was like, oh, I need a workbench. People working at a bench for like a laptop, whatever. Things that we use every day. So I remembered I had a little OLED screen, and my little laptop, which I modeled and 3D printed, fit the little OLED screen. So now we have a little screen. So let me turn it on. Anyway, see, it is noisy, but I'll move it around so you go. So the lights up.
Oh god.
And then to the bottom, so the line follower will follow its line. And then the 6-cam is just confused and just keeps going in circles. But then the laptop as well, of course.
How does that work?
The laptop is printing
That's
its. So the laptop says DPRG Roborama, May 23rd, DPRG.org, and just keeps looping that and keeps printing it like terminal. So yeah. There we
That's
go.
awesome.
Well,
You may get first prize with that.
I don't know. Why doesn't that sound? We need sound.
That's got to be some kind of star right there.
Yeah.
Yeah.
And then of course I taped the batteries underneath so it would give us some lower weight and move it forward so it balances the
You
bot
gotta
like
be
well.
careful with the bot because
So-
obviously if it tilts backwards, the sensors go up in the air.
Yep. Yeah. Just giving a little cheer of like, yay, it worked.
How do you get those little robots to go around the track?
Magic.
Watch the video from a couple of weeks ago.
Yeah. Yeah, let me go again real quick.
Oh, you got it. Okay.
It is so awesome.
It is. I was telling Mark, this is good enough for just by itself sitting on a moon day, as part of the moon day presentation.
Yeah. Yeah, I had fun with the chain. So I say there's a system called Magna Rail. I think they're out of the UK, but they do model railways, and the track runs under the sidewalks or the roads, so they can put like cars and bicycles, and they go around doing their thing. It's really cool. So I modeled it kind of that, but that's really big, and I need it really small. So these are like just over a centimeter long each, and they all interconnect. And I did them print in place, so they don't come apart anymore. There's several iterations of this, Paul. And then of course I have room for a 4mm magnet on each. But that's the length of the line follower. And then of course I had the same one for the. I don't have a frame. That's in the other room, so I can go get that. And then yeah, the motors are just an N20, and then I had an O-ring on this little spacer right here, and then of course the two motors would, two gears would push together and push the chain through the middle. Yeah. I can go get track. Oh, there's one of my first tester tracks to see how tight a radius I could get. Just a little donut, but you can actually get a really tight radius. It's pretty cool. But yeah.
That is awesome.
So if you got time on Saturday, you can come with us. I think it's out at Mesquite or somewhere. Eastfield College.
Eastfield campus it's inside of 635, but I'm not sure exactly where.
Yeah.
It's towards the north side of the city.
On Saturday, right?
Yeah, Saturday, like 3 o'clock, I think. And of course, yeah, we had to have a driver, so Roby's our driver.
Love it. Yeah, I definitely want to come. I will do my best to get there.
Yeah.
Okay, cool.
So, like I say, we don't know what to expect.
Yeah.
But I think we with Mark's hard work, we've got something that we can drag around the parade. We can do a parade.
I'm not sure the wheels are.
Yeah. Oh yeah, he's got some lightweight wheels that he also 3D printed. Hey Mark, can you get the frame too?
So your goal is to put a bunch of college students to shame.
Absolutely. Goddamn right. So, yeah. Here's the wheel. It's gonna be hard to see, I'm sure, but let me put it against my hand here.
It's really lightweight.
Yeah. So it's like 2 mil all the way around everything, and the spokes are all DPRG.
That's cool.
So, and then I just put it on a little, but it spins really good. Oh yeah, I did have a little fun with it last night because I was working late into the night trying to get it ready for today so I could come over to Doug's. And I accidentally put a motor controller in backwards and then put 11 volts to it. Ooh. Don't do that. You get flames. You get flames if you do that.
Oh,
not just blue smoke. You get blue smoke and flames.
Somehow I don't think flames are allowed in the on the Saturday event. Somehow I don't think that.
I mean, we could build it into the design and have like a little pyrotechnics as we go around, but
it starts melting and burning down.
Yeah, that's one of the tracks.
Wow, that's awesome.
So obviously one gear here, one gear here. There's a little bridge for it to pass over.
And you put magnets everywhere, and when you set the thing on it, whatever magnet picks it up, it just holds on to it as it goes around. That's awesome.
Yeah. Well, I only put 2 magnets because I'm cheap. I put 2 magnets in, reverse them so it knows which way's front.
I got you.
Yeah, and then off it goes. Yeah. Yep.
Wow.
It's been a lot of, and this is like how many 2.5 weeks we've been doing this. Yeah. It's been a blast.
That's the most creative thing that I've seen in like a long time. That is so cool.
Yeah, I think we hit reverse polarity of tantalum capacitor, and it'll smoke.
Yeah.
Crackle.
Yeah.
Well,
That's one of my
I'm going to
first.
say I saw a robot moving. That's my take on this, right?
Yeah.
Oh, I mean, we got to do a gold star for that because that was a robot moving.
Gold star?
Well,
Yeah.
technically, it was two. It was two robots.
Maybe.
Yeah, it was two robots on a robot. So what kind of star is that?
Wow, I don't know.
It's a star on a
Star
star.
on a star.
Yeah, it's kind of. Yeah, I don't think I can. Yeah, right. So I was going to see if I could share it, but I can't share it on my phone.
One of the robots waving a gold star. So because you're competing.
There's still time. There's still time. I can get a little star on there. maybe I'll actually. That's what I can put because I've been wondering because the desk is kind of empty. I've got the laptop, but I've got all this like space right here. I'll stick a wand on there with a star on it.
Well, no, what you need to do there is you need to do the trophies. You need to do the first, second, and third place trophies.
Yeah. A little, yeah, there. Yeah, a little ceramic.
Or
Yeah,
have a
cool
little robot teetering on the edge of the tabletop, you know.
Yeah, but yeah. And when I got to Doug's this afternoon, because he lives nearby an Amazon drone center. One of his neighbors across the road had a drone delivery. It was fun to watch.
Yeah.
Just basically, his drone comes down, poops the package, and then off it goes again. It's like,
I mean, the
It's so
package
silly.
falls about 15 feet.
Yeah.
You know, I mean, this is not probably where you want to do by ordering China or something.
Find crystal stemware. Right?
Yeah.
I stuck the video on the Discord. I took it on the off topic if anyone wants to see it. But yeah, it was fun. It was fun to watch. It got a few giggles out of me and a couple of the neighbors that were watching it. So.
Walmart's in McKinney has a drone center, and behind it, the drones are actually quite large. I was surprised. I don't know what the weight limit is.
Yeah.
They ain't playing. They ain't
We
playing,
dropped
man.
a probably 24-inch long 8x8 package.
It was big.
It was big. You know,
Oh, okay. Yeah.
So
Yeah. The drone was probably what, 3 foot around, like 3 foot diameter.
at least.
Yeah.
Yeah.
uh,
Yeah. These kind of look more like
Yeah.
vertical takeoff planes, I guess.
Yeah. Yeah.
It actually
Right,
has a
exactly.
wing on it.
They'll hover up
Yeah.
and then rotate and then
Yeah.
go forward.
Yeah. Move forward.
Cool tech. Very cool tech.
But,
Yeah, I wish we could show you the robot running because we could get a goal.
Yeah. Well, I mean, I can probably. Oh, we can't.
Have a computer to do it.
Yeah. Need a couple
Wow.
of technical people in here or something.
Well done, guys.
so, Doug, did you say your drive gave it up on your laptop or something?
Yeah.
That's what it looks like.
Yeah.
The thing is, you know, I have an SSD drive, and usually, I had to replace the power supply lately, so it's possible I just have a bad connection. I saw, you know, I didn't put in one of the little things right. You know, I'm hoping. We always can hope.
Mm-hmm.
So,
Yeah. But right now, it's on the insert boot media and press the key.
yeah,
Hmm.
not cool.
Not cool. No.
Yeah, that's when you go back.
Like I said, on this project, this is the second time I've had computer problems. The first time, power supply just died. Just I heard a noise, poof, you know, that was
Ooh.
it. And so I went down to Micro Center and got a new power supply. So you know, it only cost me an afternoon to get it all back running again. So I thought, you know, and since I was using a Pololu, what do they call it, orangutan, baby orangutan, that's on that thing, I had to reconstruct the flow, you
Programmer.
know. So I ended up, taking, and I also the sensor, it came with a library, but the library was, you know how they are, the kind of, and also it was an Arduino, so I had to get it transferred into ROS-C, C+, and then I had to tune it up so that it would work in, it wasn't too hard to get it to work, just a sensor, but you got to have it inside of a loop. That took a while, but yeah, I got it done. I think, was it today? Yeah, I guess it was today. This morning at about 1 o'clock or 1 p.m. So, yeah.
Yep, you guys are doing extraordinary effort on that float.
Yeah. Fun adventure.
Really neat.
I think this is what this is. It's my computer is telling me that Win 10 is dead.
Yeah. Time to move on.
Time to move on. The thing that's sad is that I have another computer here.
Yeah.
That I
really nice
bought
one.
earlier this, like Christmas. That's, it's like, it's got, the
It's fancy.
dual exhaust, and you can rev it up and everything, but it's sitting over there. I want to transfer all the crap from the old one to the new one. I guess that's gonna happen, I guess.
Yeah. No, it's easy. You just take out the SS.
Well, now you don't have to
Put it
if
in
the
there.
hard drive died.
Huh?
You don't have to now if the hard drive died.
That's right.
Well, I have can't remember the name of the company, but I have storage on in the cloud. So they'll either send you a new hard drive if you want that, or you can sit there and see how long it takes for them to transfer 3 terabytes. But we'll get anyway. So that's the advantage of having a separate data drive as opposed to everything on the system drive. And
Yep.
so anyway, yeah, guys. But I'll describe what happens. The little robot comes around the track, and then when it comes to a piece of wood, it stops. You move the piece of wood, and it follows you as you move the piece of wood around the block. It does that 3 and then times the video ends. So now you know. But anyway,
it's pretty cool.
Pretty cool. And we did a test last week to see if
it's a very makeshift test.
We could move.
It's like, can we pull
move this thing? We
so
think
his little bot, we piled it up like a big Jenga tower on top of it, just put all the weight on it and watch it try and struggle around the track. It was great. It did it.
So that's the thing. So it's Dallas College, Eastville campus.
Yeah.
Can you get in the room?
I'll put the details on Discord and email them out.
Yeah.
Okay.
Cool. If you come and you have one, wear your DPRG t-shirt.
Yes. And if you don't have one and you'll remember, come see us and we'll get you one.
Yeah, if you remember, I believe we have a couple of 2Xs, 3Xs, and 4Xs left. And
Pat, do we need to ship you one?
I don't know if you can afford to ship me one. If you can, 2X.
Okay, gotcha.
I'll reach out to you with an address, see how much it would cost. It's more than the t-shirt, I bet you.
Yeah.
I'm sure it will, but it's okay. Okay, yeah, let me know.
Don't worry, we'll get it to you, Pat. I thought we took care of that, but if we didn't, you need one.
Yep, you Tom.
Okay.
Cool.
Yeah. And actually, I think we have a couple of extra larges.
I
don't think we have any larges and mediums though. We might.
If you have an extra large, I'll take one.
Yeah.
Do we have any members that small?
No.
What we did
We like to
in the
think so.
initial order is we took the order and we doubled it. We should have been a little smarter. Anyway,
Double the
so-
sizes, like large to extra large, or no? I'm not kidding.
Yeah, we should have probably made more extra larges and larges.
Yep.
Yeah,
Yep. That's okay. We got a few.
and we occasionally get
Yeah,
a meeting.
if you guys have an extra large, I'll take one.
Okay, Mark. Mm-hmm.
All right.
Yep.
Yeah, for sure. At the next meeting, if you can make the next meeting,
Yep.
we'll go back there and get you one.
Yeah. Or the next Wednesday when we come and work on Roby.
Yeah, next Wednesday.
Oh, yeah. Also, we're having bi-weekly Roby work. Not just Roby. We're working on robots, but Roby's the primary robot that we're working on. But every 2 weeks, every second Wednesday, at the Makespace.
Okay.
When is the next one?
I don't know. Let's say next week. Let's say next Wednesday, because tomorrow I'm probably going to be here again, finishing up the bot.
Okay.
Yeah, we have to put some sort of presentation together too. So,
Yeah.
a lot of pictures. We're not going to do a lot of text.
No.
Yeah. So, anyway.
Yep. It'll be fun.
Good stuff, guys.
It'll be a lot of fun.
I love that. I love that thing. That is just such a cool thing.
Yeah.
Yep. As long as it doesn't catch on fire, we'll be good.
Well,
Mark has
done,
made it out of phone boy so that if it does fire up, it'll be
It'll be
spectacular.
spectacular. Yeah. It will. All right. That's all we got.
Well, thanks, guys.
Boy,
Up next-
if you guys don't mind, I might just snip out that little bit where you were demoing, showing the box with like the lights going and the robot going round and round, and seeing it around the DPRG media.
Are you saying you want to see it again, Paul?
Yeah.
Okay, Mark.
Hey, we could probably do it with the lights off too, and have a real
Some
fancy
of these
show.
lights off. I don't know. Well, we have to find out what.
I think it's just the coolest thing.
Let's find out. Probably that one too, maybe.
This one too.
Or, let's see. Yeah, it might work. All right. Has a little bit of a warm up, but yeah, the mouse just ran over my hand.
Pretty.
Oh,
That's great.
cool.
I'll make sure you can see everything. Yeah,
So
I'm
cool.
pretty sure I did get at least one can out, so it's at least 1 point earned.
There you go.
Yeah. It's mesmerizing for sure.
Yeah.
Right.
Love
I
it.
don't want to burn it out or
Thank
anything.
Thank you.
Yeah. Yeah, the motors do get a little hot with all that friction. But, we'll deal with that next time.
Only gonna last
This is
Saturday,
the
right?
quick- Yeah, this is the quick and dirty version.
But it's a lot less
Little lithium
than it
grease
was
then.
last week.
It's a little less dirty.
So now you're on the horns of a dilemma. Do you like test it to make sure will last through the whole day by letting it run for a day, and take the chance that it's going to break and it won't be available at all to hopefully.
Well, yeah.
The event is
Put it on the
only
shelf
2
and keep
hours
touching.
long. It's between 3 and 5.
Yeah.
I remember that, and because
Yeah.
who knows? Like I say, we don't know if there's. We got one paper saying there's a competition, and then we have another piece of paper that says it's a parade. So it may be a competition and a parade, or it may be just a parade that
Mm-hmm.
going to be judged as a competition. We don't know.
There we are. There's no point going on. Yep. Must have
We have no idea. Like things like, turn radiuses or any. We have no idea what the core is going to look like. And
yeah.
You guys are doing the DPRG proud.
Yeah, man, should have done sound as well. Dang it. Lost points there.
Yeah, you still have a few days.
Well, yeah, but I literally hot glued this whole box together, and all that's sticking out is the battery cord now. So I don't want to rip it apart.
yeah, there's got to be. We got a bunch of hole for the robots. Where is that robot going to fit in there?
It's going to sit on this robot's going to be like underneath here.
Yeah, but are these going to be too close?
No, it's going to no, because it won't be too close. It'll be above it.
Okay, and it's going to have 4 wheels on it.
Hopefully.
So that keep it. Hopefully, we can make it neutral, weight neutral. That's what we're looking for.
Yep. If nothing else, we can go back to the paperclip.
Or they're on set, right?
We use the paperclip as like a little tow hook. It works.
Yeah.
Trusty paperclip.
Very neat.
It is fun. It's been a blast. All right.
Boy, you guys stole the show. Good job.
Okay, I have a little something to present tonight.
Ooh.
First time in a while. So, can you guys see that?
Mm-hmm.
Yeah.
So that's my latest acquisition.
Ooh.
Arduino Uno Q. And I decided I wanted to try to shrink the size of my robot a little bit, or the controller footprint. So from a Raspberry Pi and an RP2040, I decided to go to this guy.
Yeah.
And so I'm not happy with the software. So fire up the software, and it finds the robot. I've got it connected by Wi-Fi right now.
Yeah.
Oh.
So yeah. Log in. Ah, it's going to do this to me again. So the software is full of bugs.
Cutting edge.
Bleeding edge, yes. Try again. I don't know why it's doing this.
Because you're demoing it.
Yeah.
It was working earlier. So it won't.
Demo mode, I guess.
Demo mode on their software, yes. This shows you how well it works.
You have to reboot your robot.
I don't want to.
Third time's a charm.
Yeah, that's what I was going to say. Third time.
There it goes.
Yay!
So there I'm in through the app over Wi-Fi, and you can go and click on something. So like the Blink LED app, it's going to open it up, and it opens up to the README page. And then on the side, on the left side, so you've got the files. So there is, so the Arduino sketch for the Blink. So it just basically listens and publishes the state according to what the Python program is sending. It does that through Arduino router bridge. And basically there's a Python script. Same thing, which is gonna, basically it's gonna listen, and when it gets a call to the LED state, it's gonna run it's gonna send out the LED state. So it's gonna sleep for 1 second, and then it's gonna make the state equal to not the state, and then it's gonna call the Arduino program and tell it, hey, here's your LED state. The Arduino listens to it. It's going to listen because there's a provided message for the LED state. And when it gets to the LED state, it runs the set LED state routine, and it's going to run it and write the state, high or low. So basically it turns the light on or off from the Python program. Pretty simple. I don't like it because you don't get any errors. Your program just craps out, and good luck figuring out what's going on. So I started working on, basically I've created over SSH. I can get into the robot over SSH and into the Arduino apps, the same directory that I had. I created a couple programs I've been working on, just testing. So here's one of them. So it's Python. I don't have anything going into the to the sketch really. It's just a basic sketch that I'm using right now. Just turn it on and off, and I can see as soon as I power it up, the LED is blinking on the Arduino portion. I've got this guy. So I loaded OpenCV into it and NumPy, and basically just to test it out and see what's going on. I was doing a test to see how many frames I can get per second. And let's go to this. So if I run OpenCV, my this test basically takes a while to start up. So 5.6 to the minus 10 for frames. But there it goes. So I'm getting about 7.5 frames per second. Right now I'm processing the image. So the top left is my original image, and the bottom left is the mask extracted using LED color for orange. And then I just superimpose the can onto the
Hey Pat,
yeah.
can you what if you turn off the video on?
Oh yeah, so I'll show you that. So right now I'm all over the place on processing. If you look, I'm at 13, I'm at 1, I'm all over. Which is, you know, not fantastic. But if I go in here and let's say I turn off my videos, I'm not showing them. So then when I run it, if I just run the program without the videos coming up, so there I'm a solid 7.5 frames per second is what it's coming up with. So which is acceptable, not spectacular, but it's enough probably to track something. So, and I do have another one I've been just testing out. So trying to get, oh, did it crap out on me? Trying to get better color detection. So I've got this guy.
So you can't actually hook up a camera to this yet, right? They don't have.
Yeah, that's a camera, USB camera.
Oh, it is. Okay.
Yeah, this is a USB camera. So I've got this thing sitting on the robot. I've got a motor control shield on there. An L298P shield. And I have a USB camera connected to it.
Okay, all right.
So this one here, I've been playing around, and I tried to convert the image to 9 colors. So it basically goes through, finds the closest colors it can find, and represents it that way. So I thought it may be a good way to get rid of some of the highlights and the shadows and the lights from the can. So far, it's not bad. Except the DeWalt writing that you see upside down is actually yellow. And there is a yellow color that was represented in there, but I got rid of it. So
Are you using, I used to think they called it cartoon mode. It limited the number of colors in the image.
no, I'm not using cartoon mode. This one, I'm using, basically, I've filtered out some of them, but I'm using an LAB palette, essentially for, this is an RGB, a BGR palette on this guy. So there's a black, there's a white.
Yeah.
I've commented out the red. I've got green. I got blue somewhere in there.
Okay.
I've got orange, and I've got gray. So that's what I've been playing with, just trying to see, okay, what does it come up with for colors? And I just apply it. It's pretty simple. Just apply it, display it, and see what's going on. So I did that to try to say, okay, well, if find the closest color you can find in here. So instead of having to play with shades or something to see how it would go. So far, it's not too bad. So I'll have to see how it works otherwise. So I'm just in the testing. So right now I have I've got the Arduino app libraries commented out. I'm working on getting them imported into a virtual environment, so that I'm not reliant on the app lab to get things running. And it's a little bit of a challenge, but I did find an article now on how to do it. So I'm going to try to pull them out and then eliminate essentially the Arduino app lab completely. So that was about it. It's been my effort this week. I've actually did some stuff towards roboting, and so that's interesting.
That's pretty neat, Pat. I was just reading about the Arduino Q because I haven't really tracked it. But it sounds like it's like got effectively a Raspberry Pi and you could say maybe a Pico class microcontroller altogether, and that's really what you're showing.
Yeah, so it's almost up to the speed they say of a Raspberry Pi 3B plus. It's close.
Yeah, not a 4 or 5.
It's not a 4, definitely not a 5. But I was impressed to see that it's 7.5 frames per second for processing. I don't know what the latency is going to be for each, from the initial capture and the starting, but it's something I've been trying and looking at. It's definitely slimmed down the footprint for the controller, so there's no more Raspberry Pi 4 and everything that went ahead with the RP 2040 that I had that didn't have an easy to mount motor driver. So everything fits onto one board. I'm using the analog channels. Analog 1 is a battery feedback. 2, 3, 4, 0 is a battery feedback through a voltage divider, and 1, 2, 3, 4 are my encoder signals coming back on the analog inputs. So they're going to be used as digital inputs on interrupt routines, and I'll see how it goes.
Does the Q have a SSD or is it run off of an SD card?
It has, I don't know if it's eMMC memory.
Okay.
Yeah.
And so it's built in. Like I say, I was able to, I just loaded it up as an SSH drive. And, there's your full Linux firmware on there. I'm able to add the Python libraries, no problem, into the to the system to get it going. I can access the through VS Code. I can access it. I'm on a remote connection to the board now, so I'm able to program it as well remotely. I should be able to develop and save the Arduino file, possibly load it. I haven't figured out how to load it as of yet.
Any figures on power consumption? Is it a lot less than a Raspberry Pi 3 or?
I haven't put a meter on it. They're saying provide it with 3 amps.
Ooh, wow.
So I bought, let's see if I can get it up here. I was looking for a small PD power supply. And so I bought one of these. Fits into a cigarette lighter in a car. And I promptly...
Are you showing us something?
Are you sharing something?
Oh, you're not seeing that guy?
Nope.
Oh, okay. Oh, let me try this again. There's more than one way to skin a cat here. Okay. Copy. Okay, you guys are seeing that screen?
Not
Am I
yet.
not sharing anymore?
No.
You're not sharing anymore?
Okay. Why am I not sharing it?
Come on, Pat, you're the IT guy. Come on.
I'm not an IT guy. I'm an electrician. Where is my video? Share. Share screen. Let's share that guy again. Okay, are you seeing my screen?
Yay.
Yes.
Yeah.
Oh,
Can you see
wow.
that?
A car
Yes.
adapter. Nice.
Little power adapter. So it's got a PD port on it. It provides 38 watts. So that is what I used. I tore it apart because of the size. There's a fairly small circuit board in there, and I mounted a set of terminals on it and wired it up. So it's working well.
Nice.
Beats working in your car, right? You know.
Exactly. Beats working in my car, especially this time of year when we got 6 inches of snow yesterday. So I guess they forgot to tell Mother Nature that it was April. Let's stop sharing that guy. So the other one I did is I bought one of these guys, fairly small, little USB PD adapter, so you can power up, stick power into the side of it, and you can power up whatever device, your laptop or whatever, through this guy. It's really small, like, there it is. So it's very small. The problem is it's not working right. So it powers up the Arduino board, but it's not recognizing the USB camera that I had plugged into it. So then I ended up buying a little Y pigtail PD adapter. So it powers up. I power it from that little cigarette adapter board I bought. Provides the 38 watts into it, and then on the other adapter, on the Y adapter, there's a full-size USB port. So I plug in the camera to it, and it's working well. So I can see the camera, and obviously I've been showing you guys that it displays from it. So it's working out. It's working out well so far. I'm still scrambling. Got a month and a half left to go. I'm trying to get something going. I want to compete. It's probably going to be in my living room floor. So I'll see what happens.
Excellent.
Pat, does that chip claim any AI capabilities? I thought it did.
Yes, it does. So they use what's the service? A bunch of different boards use it. I hate when you put me on the spot like this.
Gosh, Pat, come on.
Oh, I haven't looked into it yet. I did use it on one of my other boards.
But it
Sorry?
doesn't have like a
An
local,
online service. He's not sure.
it doesn't have any local AI style compute. Like there's no tensor
So-
core or
No, there's no tensor core
Nothing
on
like
it.
that.
Hmm. Yeah.
I did think that it had a, what
So
do they
you're talking-
call it?
Go ahead, sorry.
APU? Didn't it have an APU
So the
or?
Ventuna had the APU.
That's the
Huh?
Ventuna. That's the
Ventuna.
Ventuna.
That's the bigger one.
Yeah.
Well, the more expensive one.
The more expensive one does have it, but I thought the little one had a 13 tops or something.
Yeah, I'm trying to advanced features. Oh, what's the name of that guy? Operating system, mouse, keyboard, wireless. Tom, I believe you use the same AI website. Somebody else did as well. It's just not coming to me.
So it's a little disappointing that the main CPU power is only rated comparable to a Raspberry Pi 3 because the I was kind of thinking, well, maybe you could run the ROS navigation stack on it, because clearly you could run it. Apparently, it'll run Docker, and so you could run. Therefore, you could run ROS on it. But the nav stack is considered to max out a Raspberry Pi 4.
Yeah.
So that's
Paul?
like
Oh, there's
almost.
a big brother. There's a big brother that's coming.
Yeah.
Oh, really?
That's got like
There's a-
4x, but it's like $300.
$350, I think, US is going
Yeah.
to be.
Yeah.
But it's not, it's announced, but not, it's still not out.
Yeah.
But it's like, it's like 40 tops and it has, so it does have a built-on AI unit, processing unit. And it also has, I think 64 gig of eMMC. So, you know, there's no need for an SD card because it's all built in.
Yeah.
But that's, you know, that's but what the real value I think of this is that Pat can start to use their environment and see if he likes it, and he didn't have to put $300 in it. I mean, you know, if you put $300 and you didn't like it, that's a pretty big change. But for $60 or $70 or whatever it costs, Pat's able to. They use the same. What do they call it? Arduino Creator Lab or something.
Arduino App Lab or Arduino Lab app.
Lab app, yeah. So they use a lot of the same tool chain. And they both have Snapdragons in them. So it's conceivable. I'm sure there's always problems, but it's conceivable that anything developed on this board could be done on the more expensive one. Though that might not be the way you want to go because you have so many more resources on the other one. But anyway, I thought this was I'm glad that Pat did the plunge because that was real interesting to get to see somebody who could provide real feedback on it.
Yeah, for sure. And I mean, I wasn't trying to diss it or knock it at all. That was a neat demo that you did, and interesting because I didn't really have my head wrapped around what it was. So thanks for showing it, Pat.
Yeah, but I think the Big Brother one will do the ROS directly. I think you can run ROS on it.
I think the Big Brother one rivals the Raspberry Pi 5.
Yeah.
Plus with the NPU or on it, so it should be quite good at doing some vision processing or whatever. So the problem I've had with this one, and they're going to have with the other one, is they're just coming out with the daughter boards that fit underneath. They released the newer version, and then a few days later, actually, I think it was a day or two after I bought this one, they released that you can get the daughter boards. So a lot of the I/O on the daughter boards are 1.8 volts. So that's something to watch here when you're using the extra pins, because there's a lot of extra pins that are available to control things. But you have to watch on this board, and I'm sure on the other board as well, that they're going to be 1.8 volts.
Oh. Huh.
So we'll see. I don't like, and it's been mentioned before, why the LED matrix. You know, you're going to all this trouble to try to come up with a higher powered board, and you stick on a LED matrix on the front of it, which is going to be negated if you're putting a hat or a shield on top of this anyway.
Right.
You know, you can't see it. So what's the point?
Yeah. Yeah, I think I have an Uno 4 and it has the same, not as many LEDs, but it has a big array.
Yeah. So it's why, I don't know, but just one of the quirks.
Is there a solution for a graphical desktop, like be it remote VNC or anything like that?
I have.
Oh,
here I can show.
So it does have a video controller on it. You just have to access it through the USB-C.
Yeah. So if I share my screen again, is it going to share? Okay, so you're seeing my screen. So let's go to Mr. VNC. Oh, refuse. Why is it? Oh, I'm not running it. Okay. What am I looking for?
Yeah, the next step is to take this drive out and see if I can read it on a computer. To the USB port. Yeah, one of those.
You say it's SSD, but it's not just a stick, is it? It's
No, it's not. It's actually it's an older SATA drive.
Okay.
So
I have a USB SATA connected, like I think at home, so
yeah.
I remember I'll bring it tomorrow.
So when you go into it over either in the desktop or in the over SSH, it boots you into not SSH but VNC that I installed desktop and starts up the Arduino app automatically. I haven't changed that. But you can shut off the app. You get to the desktop.
Okay.
And it's definitely not powerhouse. It's slow. There's, you know, your Linux desktop, everything there. It's way faster. So you fire up your SSH lab, or you can go into settings. So image viewer, system settings. It's a regular Linux distro. I put I think it was Tiger VNC on it, just to run it. But I find it slow. I think it's taxing the processor trying to run this, plus my SSH connections in the background.
Yeah, I just hooked up the little SiPede camera to try to figure out how much current it drew. It looks like about 300 milliamps at 5 volts. So You know, you can kind of do the same sort of thing with this thing with a whole lot less current draw.
I agree. So what I was after here was to try to shrink everything down a little bit and try to go to like just an Arduino board with a shield on it.
Yeah.
And
And how are you getting networking to that board, Pat?
there's built-in Wi-Fi.
Oh, okay. Okay. Got it.
Can you, I'll share my screen again. They just turned it off. So you can see the Wi-Fi board
Yep. Yep.
in the bottom left corner. There is
Yep.
provisions for an external antenna, but I don't know if you would have to unsolder a resistor to be able to use it. Change your resistor position. I'm not sure. So
Pretty cool.
on the back, there's the connections for the daughter boards,
Hmm.
and they recently did come out with accessories, but I don't believe they're on this site here. They've got these things, Modulino, which are just I2C devices that plug into the quick connector. So I have an IMU plugged in. I have an IMU and a front-facing a VL 6180, I think it is. Time of flight sensor, front-facing, plugged into it, and I'm able to see them both. So it was an interesting buy. I don't know how viable it is for how much I want to do, but I'm going to be interested to see if I can do vision processing and run it with the CAN.
Hopefully it won't become Edison II, you know.
There was just an article, I think it was last week, about the Edison, saying that, you know, they got a whole bunch of universities and colleges to buy into it and start building with it, and they've abandoned it.
Yep, yank the plug.
I just had PTSD moment. I got a bucket full of them sitting over here. Anybody want one?
A bucket.
All right. I'm going to have to head out.
I think I'm funny.
All right. I got to head out. So Doug and I are going to hang up on you.
Okay. See you guys. Good job.
Okay, don't, if you can
It's in
join
a
us,
bucket, and this is
Try to
what I
join
can
us.
just grab right fast. I got at least double this, maybe triple. Anybody want one? Or two? Or 20?
Bring them to the next monthly meeting.
There you go.
I will do that. I will do that. Because I tried to sell them and nobody, even though nobody's buying them.
Well, that's all I had, guys.
Cool.
Cool, Pat. Thanks. That was a neat demo.
Anyone else?
Yeah, I know the thing has huge connectors on the bottom. Has anything been offered to connect through things that way?
Yes.
Some sort of.
There is, I believe there's 2 boards for it. They were announced this week.
Okay.
But I can't, I'm on the store. And I'm looking to see if I could find them.
Maybe they're all pre-order status, you know.
They were pre-order.
Oh, they were. Yeah.
But I'm just looking to see, okay, what's the description?
Yep.
And I don't even remember what they're called. Daughter card.
Yeah, I think we were talking about what you would call that. You know, the ones on top are hats, and the ones on the bottom, I guess, are underwear or something. So.
See, the thing is, that sounds that sounds not so bad, but kids these days are changing the names of things. Now I'm going to use two words together in the context of what kids use them for today, not what we use them for. There's a concept called raw dogging. Now, I'm old enough to know what that really means. But
you're taking this to a whole new level here.
Yeah, what it means to kids these days is doing, like, the phrase is, I'm going to raw dog this air flight. What they mean by that is I'm not taking books, electronics, music, nothing. Nothing. Read whatever. I'm going to sit in the chair and look straight at the back of the chair and do absolutely nothing the entire flight. That's what it means today. It's not what it meant to most of everybody in this channel. I'm pretty sure about that. They got other phrases like that too, and I'm like, you guys aren't talking about what I think you're talking about, are you? And it's pretty public on the thing. And yeah. We would. Oh my God. I'm like, they need to go read the Urban Dictionary before they start using any new language anywhere. That's just all there is to it. Okay, maybe they don't need to read the Urban Dictionary because that's, never mind.
It's an overlay, I think it's called.
Yeah, leave it to me to lower the bar or whatever, or bring the thing into.
Here, see if I can post it into the chat. I don't know if this will work. So there's one for cameras.
Wow. So maybe 3 cameras, huh?
Yeah, so there's an official one. There's two official boards that were released. So one of them is for cameras, and then the other one was just for I/O, for like more ports. And I can't find the article. So there's some crowd supply stuff I can find on it. But I can't find the actual Arduino article I had. That's it for me, guys. Does anyone else have something to present tonight? Questions? Do we call it a night?
I think so.
Okay, guys. I'm going to stop the recording. And I guess we will see you guys next week.
Next Tuesday.
All right. Good meeting. Thanks, guys.
Thank you.
Good night.
Good night.